Good afternoon, guys. Sorry I am not able to be here for your class today, but I'm gonna be going over reflections with you via video. So a reflection. We did translations last class, which is another type of transformation. Today we'll be doing reflection. A reflection is a flip over a line called the line of reflection. And you can remember that it's a flip because of the F and L in the word reflection. Okay? Each point and its image are the same distance from the line of reflection. The x-axis and the y-axis are common lines of reflection. And in fact, you guys will only be dealing with reflections over the x and y-axis, nothing else. Reflections are also result in congruent polygons. Just like when we did translations, the size and the shape of the polygon never change. That goes for the same thing with reflections. Okay? All right, so let's look at an example on the whiteboard. So first off, I have a triangle up here. It's triangle XYZ, right? And we are going to reflect it over the y-axis. I already have written down the coordinates for XYZ, and we're going to kind of see what happens to them after we reflect it. Now, if you remember what I said just a couple minutes ago, that every point that's being reflected is going to end up being the same distance from the line of reflection, okay? So since our y-axis, which is right here, is our line of reflection, we know that every single one of these points is going to be the same distance from it. So for instance, if I'm looking at point Z here, it is 3 units away from the y-axis. 1, 2, 3. So when I reflect it over the y-axis, it's going to stay 3 units away. 1, 2, 3. And that will be my new Z point, or my Z prime. I'm going to do the same thing with the X. The X is 1, 2, 3, 4, 5, 6, 7, 8 away. So same idea. 1, 2, 3, 4, 5, 6, 7, 8. 2. That's your X prime. And then I'm going to do the same thing for the Y. Count the Y over. I know that's going to be 8 over. And that will be right up here. And that's your Y coordinate. Now you guys just play connect the dots. And there, you have a reflection over the y-axis of triangle XYZ. All right, and that's what it would look like. If we were to reflect it over the x-axis, pretending that this is the triangle that we just did, when we reflect it, it would actually end up looking like that. All right. Unlike the translations, the reflections are going to change the orientation of the triangle. So you need to be aware of that. Now, let's look at the points. So I wrote the original points down. So now we got to figure out, all right, what are the new points of it? So I'm just going to go back and look over here. So when I look at the x, I know that I'm 1, 2, 3, 4, 5, 6, 7, 8 over up 2. So my new coordinate is 8, 2. My next one for the y, well, I'm going to come over 8, and then I'm going to go up 1, 2, 3, 4, 5, 6. And then for z, same idea, over 3, up 2. Do you guys notice anything about the points? Comparatively, the new points compared to the old points. I'll give you a minute to think about it. Well, hopefully you notice it. But when you reflect something over the y-axis, look at your two x points. If you notice, when you reflect it over the y-axis, your x value of the ordered pair became its opposite. Same thing for your y. If you look at your 8, it went from negative 8 to positive 8. Negative 3 to positive 3. When you reflect something over the y-axis, your x values go the opposite. And when you translate something over the x, and then your y values will become opposite. Okay, let's get back to the notes. I'm going to do 2 more examples with you, and then you will be cut loose to do 3, 4, 5, and 6. So let's look at number 1. Number 1 says rectangle ABCD with the vertices A, B, C, and D. All right. So I've already taken the liberty and I graphed the original shape, which is a rectangle. All right, and it tells us that we are going to be reflecting this over the x-axis. The x-axis is right here, remember? So let's just start reflecting it. So remember, every single point is the same distance away from the line of reflection. So if my A is right here, okay, if I'm going to reflect it over the x, it's going to be 1 away from the line. All right, so that's my A prime. Then same thing with D. D's 1 away, just like that. That's D prime. I'm going to do the same thing with B, and then of course C. Okay, then connect the dots. All right, and there is my reflected shape. I want you guys to think about this. If I would fold this paper on that line of reflection, the x-axis, these 2 shapes would match up perfectly. Now let's figure out the coordinates of our reflected polygon. Okay, so if we look at A, since we're reflected over the x-axis, my y is going to change. So I'm going to have 1, -1. And then for B, I'll have 1, -7. And then 5, -7. And then for D, it'll be 5, -1. Now, if you guys know your quadrants, as in 1, 2, 3, 4, that you know that when it's in the quadrant 4, like it is now, that it's going to be positive, negative, which is exactly what we have here. But if you're able to remember that little trick, that when you over the x-axis, the y changes. Over the y-axis, the x changes. All right. Let's go on to number 2. Number 2 is a rhombus, PQRS, with the vertices P, Q, R, and S. And we're going to flip this over the y-axis. All right. The y-axis is right here. All right. Same idea. We are going to make sure that everything is at equal distance from the line. So if we notice R is 2 units away from the y-axis. So when we regraph it, it's going to be 2 units away. So there's my R prime. So I'm going to do the same thing with the Q. The Q is 1, 2, 3, 4. So 1, 2, 3, 4. And there's my Q prime. All right, same thing with P. All right, so P's 6 away, it looks like. 1, 2, and that's my P prime. And then finally, S will be right here. Connect the dots. All right, make sure everything is labeled, obviously. Now I have to go through and look at my points again. Now, since I know that it's over the y-axis, my x's are going to change. So if I have P, which was originally -6, 4, now it's going to be +6, 4. And then for Q, it's going to go from -4, 7 to +4, 7. And then so on and so forth. Now it's going to be your turn. You need to work on numbers 3, 4, 5, and 6. If you still need some extra help, you can watch the video again, or I've placed another video in the folder for you to watch. Have a great weekend, guys.